Okay, we're going to be looking at Unit 8, Similarity Review. And just like normal, I don't really like the videos to go over 20-25 minutes long, so I will be kind of working the odds and then letting you do the evens, and I may skip an odd every now and again if it's a lot like something that I've already worked. Okay? Sorry, just organizing my colors here. All right. So this particular unit was all about proportions and similarity. And so we start with sort of a basic concept of what does it mean when I have a proportion comparing two sizes, and what if the sizes aren't the same to begin with. So for example here, grams and milligrams are not the same size, so I can't compare their proportions until I get them to the same measurement size. But I do know that in 1 gram, there are 1,000 milligrams. And so what I can do is, instead of having 3 grams, I can convert that to 3 times 1,000, and it's going to become milligrams. So remember, you're always converting the bigger one into a whole bunch of small units. And then that's going to give me, my units are going to go, and that's going to give me 3,000 divided by 3, which is 1,000. And what this 1,000 tells me is that 3 grams is 1,000 times larger than 3 milligrams. Okay? All right, the next ones are some algebra, so some sort of basic algebra skills here. Just can you solve a proportion? And so we've got that cross product property or butterfly method where we multiply the extremes together. So in this case it would be 8x equal to multiplying the means together, which in this case would be 4. And then we're going to just be left with a simple algebra problem. Not all of them will be this easy. And we can always plug our answer back in and check to make sure that we are correct. Okay? So all of these are sort of worked the same way. I multiply my extremes, and that would give me 18. And then I multiply my means. And in this case, I'm going to have to distribute because I have addition or subtraction within a term. And so I'm going to distribute 4 to n minus 2. And that's going to give me 4n minus 8. And then I've got, again, just a little two-step equation here that I'm going to solve. So I'm going to add 8 to both sides of the equation. And that's going to give me 26 is equal to 4n. And divide by 4. And you can take this to decimals or you can leave it as fractions. This is 13 halves, and I could have written this, by the way, as 0.5. And 13 halves reduces to, what's 13 divided by 2? 6. I don't know why my brain won't function. 6.5, I think. I probably should pull a calculator out if I'm going to be that airheaded. I can always flip it over, right? Answers are on the back, so we can just do a quick check here. And what did I just work? I worked number 5, so there it is, 6.5. Okay? All right, number 7. And I guess I could have just checked it. Here, I'll do that for you guys so you can sort of see what that check looks like. Plugging it in and making sure that common ratio is actually the same. So if I'm checking my work here, then I'm going to show that 6 divided by 4. So I'm going to hit Control Divide, 6 over 4. Decimal point, so I can get a decimal point. So this is my first ratio. And if I did the right thing, I should have a common ratio. So I would do 6.5 minus 2 over 3. And see, that common ratio is exactly what I'm looking for, meaning that 4 is 1.5 times larger than 3 is. Okay. All right, so moving on. Another problem like that one, we just have variables on both sides of the equation this time. So I multiply my extremes. So I'm going to multiply 5 times x plus 2, and that's going to be equal to my means. So x times 4 is 4x. I just need to distribute. That gives me 5x plus 10 is equal to 4x. This is always a little confusing for people when x is sort of over here by itself and it's the smaller one. It's really fine. I can just subtract 5x from both sides still. I just want to be careful of my signs here. 4 minus 5 is actually negative 1. And I do want to solve for x, not negative x. So I'm actually going to divide by negative 1. And my answer is going to be negative 10. And again, I can always just plug my x back in to check my work. Okay? All right. One more in this section. Two distributive properties here because I have two terms with addition or subtraction. So I'm going to have 2 times a plus 6 is equal to 4 times a minus 3. So again, 2 times I have to distribute. We have 2a plus 12 is equal to 4a minus 12. And I'm going to put my a's together first. So I'm going to usually move the smaller one. It doesn't mean you have to do it that way. So now I've got 12 is equal to 2a minus 12. And then I'm going to add 12 to both sides of the equal sign, isolating my a. So that gives me 2a is equal to 12 plus 12, which is 24. And then just divide by 2 and squish it in here. A is going to be 12. And again, plug it in, check it, you're good to go. All right, number 11, this is where you want to set up your ratios, right? So it says in a basic cookie recipe, the ratio of, here's my keyword here, flour to sugar. That's my, I'm going to have a proportion keyword. So flour to sugar is another common math word. It means equals. And then 3 to 2. Just take everything to a fraction. I think it'll make more sense to you. This just says this basic recipe makes a dozen cookies if 17 cups of flour are used. So if 17 cups of flour, keeping us all lined up with our flour, in this recipe, how many cups of sugar will be needed? So this is the question, how do we find the cups of sugar? So it's 3 cups of sugar for every 3 cups of flour. So how many cups of sugar for 17 cups of flour? So I just need to solve this proportion right here. Same thing as our algebra, just a little pre-work. So we have 3x is equal to 34. And we divide by 3. And we're going to end up with, turn on, well, it's resetting. 34 divided by 3, and just for time's sake, I'll just hop back here and look. What would that decimal be? 11.3 cups of sugar. So x is going to be 11.3, and remember we always want to answer the prompt. It says how many cups of sugar will be needed. Okay, so I would say if 17 cups of flour are used, 11.3 cups of sugar will be needed. And again, I could plug back in and check that common ratio. All right, moving on to number 13. I kind of threw some different shapes here at you to see if you understand that it doesn't really matter if it's a triangle or not a triangle. If a shape is similar, all the sides are in proportion. That's all. Okay, so I'm just checking my proportions here, and so I'm just checking to see, is 24 divided by 18 in proportion with 12 divided by 12. And so you can see here, this long side does not have a common ratio with the short side. And because they don't have a common ratio, then I would say that these are not similar. So you're just checking to see if that common ratio is actually happening. Number 15 says they are similar. And because they are similar, we should be able to find the common ratio. Okay, well then 12 is to 8 as 15 should be to whatever that side is over there. Okay, so we'll just say x. 12 is to 8 as 15 is to whatever that side's going to be. Okay, and then a quick solve here. So we're going to get 12x is equal to 15 times 8. So that's going to be 120. And divide by 12. And x is going to be 10. Right. And I could kind of check that with the common ratio concept as well. All right. Number 17 says the polygons in each pair are similar. Solve for x. So we're doing the exact same thing here. We're going to say 18 is to 24 as x plus 4 is to 16. And multiply 18 times 16, giving us 288, is going to be equal to 24 times x plus 4. Anytime there's addition or subtraction, a lot of times I'm going to do this right here to remind myself that I do have to distribute that 24 to both terms. So we have 288 is equal to 24x, 24 times x, and then 24 times 4, which is 48 times 2, which I think is 96, but I'm just going to double check. Yep. Right, and again, simple algebra here. Subtract 96 from each side. So we have 288 minus 96, which is 192. Bring down your 24x, get rid of that 96. Divide by 24. And your x is going to be 8. Okay. Moving on, number 19 says, state if the triangles in each pair are similar. If so, complete the similarity statement. So we would check to make sure that 21 is to however big this is in proportion with however big this is in comparison to 42, right? So I could find dW by taking 42, so I'm finding dW by taking 42, the length of the entire side, and subtracting the part that's not included on dW, telling me that this portion is 18. Okay. And then if I want to find this whole length, right, then I can just add 21 plus 28 and get 49. So I'm just going to check my proportion of small triangle to big. Okay. So I'm going to check DCW with UVW. So the question is 21 over 49 equal to 18 over 42, right? So if I go to my calculator and I check 21 over 49, I get 0.42. If I check 18 over 42, I get 0.42. So you can see I get the exact same ratio here. And so that tells me these are similar. So I would say, now you have to pay attention here, UVW UVW is going to be proportionate with WCD. So stay in order. Make sure your side lengths are actually proportional. All right, continuing on here. Number 21 says find the missing length. Here's my missing length right here. Okay, so we have a big triangle and we have a small triangle. My small triangle is VSR. And so we have 5, 6, and something I don't know. And then I have a big triangle. My big triangle is VTU. And this side length is 20. And this side length is 32. And this side length is 24. Right? And so we kind of need to see them separate, but understand, like, if the triangles are similar, then the part is going to be proportional to the whole. So 5 is to 20. 5 is to 20. As VR, which we don't know, we're calling it X, is to the whole, which is 32. 6 to 24 is also in proportion. I could use it instead of the 5 to 20, right? So I could have said 6 is to 24 instead of 5 is to 20. It doesn't matter. And then I want to solve this. So 5 times 32 is going to be 160. So I'm just solving this now. I'm kind of out of order. Out of room. Is equal to 20 times x. So I divide by 20. And I get x is 16 divided by 2, which is 8. Okay. Okay, 23. 23, you're given the similarity statement. We like to be given the similarity statement because it makes our life easier in terms of writing our proportion, right? Because now I can just look at this and know SR is to SG as RQ is to GH as SQ is to SH. Okay, so then I don't know anything about SH and I don't know anything about SQ. So I'm just not even going to be worried about that, and I'm just going to focus on this relationship right here to help me solve for X, which is this QR side over here. Okay, so SR is 6, SG is 3, so 6 is to 3, as RQ, which is 2X, is to GH, which is 6. Okay, and then again, a proportion to solve, so I'd say 6 times 6 is 36, and 3 times 2X is 6X. And this one's super easy, just divide by 6. And I get that X has to be 6. So anytime they give you the congruent statement, boy, that's an easy problem. Just set it up and go. All right, last one that I'm going to work for you. Little bit tricky. It says throwback extension. So we're going to take a little bit of what we've learned and mash it together. It says find the area of each triangle, which is 1/2 base times height. You will need to find a height or part of the base using Pythagorean theorem. Round intermediate values, the middle values to the nearest tenth, and then use those rounded values to calculate the next value. Then we'll round our final answer one more time. So using a rounded value in the middle is basically what's happening. Well, if I want to find the area, I know I need 1/2 base times height. which that's fine. Here's my base. But what I don't know is what's the height. Well, because these two are equal, these have to be equal, which means they have to be 90 degrees. Okay? And it turns out this is actually going to bisect this. So this is going to be 2.4 and 2.4. And so I need to find my height of my triangle. And so I'm going to use Pythagorean theorem to do that. So this would be like my A, my B, my C. So I'm going to say A squared plus B squared equals C squared, remembering that C is always my hypotenuse. So we're going to have 2.4 squared plus B squared is equal to 5 squared. Okay? And 2.4 squared is 5.76, and 5 squared is 25. So then I just want to subtract 5.76, and that's going to give me, let's see, 25 minus 5.76, which is 19.24. Then I can just take the square root of that answer, and I'm going to end up with B being approximately 4.386, which rounds, because it tells me in the middle of the problem, round to the nearest tenth. So my B is going to be approximately 4.4. Right? So now I have a base and I have a height. So I can find the area by doing 1/2 base, which is 4.8, times height, which is 4.4. Let's see here. 1/2. I'm just typing into the calculator right now. I'm just doing 1/2, 4.8 times 4.4. I'm just going to throw it all in at once. And I'm going to get 10.56. And then 10.56, the 6 rounds the 5. And so my answer is going to be 10.6. 25 has worked similarly, but you have to solve for this part first, right? So A, B, C, and solve for B first. All right, guys, I hope this video was helpful, and good luck tomorrow on the quiz.